Hey everybody, Caesar here. So for this one, we're gonna go and tackle the first LeetCode problem, which is two-sum. For this one, we are going to be using the 4-step process that I like to use to solve any LeetCode problem. That is understanding, diagram, pseudocode, I call it P-code, and then we actually code it. The last part is where we actually code the thing. So we're gonna worry about doing the logic and understanding what's going on first before we decide to write the code. Writing the code should be the easiest part in this whole thing. Okay, let's get going. So the first step is understanding. That one's easy. We just read over the problem and see what it says. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. All right, you may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. Okay, so I read it. We're going to return indices of the two numbers, but I find it easier to just use the examples here below to actually understand what's going on. So let's do that. So we have nums of these integers and a target. Okay, so the way that I like to do it when it revolves to any loops, I just like to throw an I under it so I can visualize it. I think initially, since we're going to go through each element, and this is useful for you to tell the interviewer, like, hey, I know a brute force way of doing this, which would be I and J, just loop through the array twice. And so you loop through this one, you start it here, and then you add the number that's in the I and the number that's in the J. So 2 and 7 adds up to 9, which is the target. Boom, you send back I and J. 0 and 1, and that's how you get the results right here. However, since you're looping through the same array twice, that's actually not optimized. That's considered in big O squared. So it's not great. We can do better. So we're not going to spend too much time on that because even though we could do it that way, I think there's a better way of us doing it in one pass instead of having to loop through it twice. Okay, so let's explore that one. Since we just want to go through it once, we need to keep a map of where we've been because we're not going to see it again. We're going to keep a map of all the numbers we've seen already and then the index in which we saw that number. If that's the case, then we'll also need another variable being like needed, the number that we're looking for to see if we've seen before. And needed will be target minus the current number that we're in. And let me show you how this looks. So we know target's 9, that doesn't change. The one that'll change is the number that we're in. So currently I is in 2, right? So we have 2. It actually is 7. Have we seen a 7 before in our array? No. We move on. But before we do, we put the number that we've seen, which is 2, and its index, which is 0. Now we move to the next one. 7, which means that this calculation changes. 9 minus 7, which is 2. And then we do the same check. Have we seen a 2 before? We have in our map. And we've seen it at index 0. If we've seen it at index 0, we can immediately exit because we found it. So we can say we've seen a 2 in index 0 and I'm currently in index 1. So return that. And that is what gives us the output right here of 0, 1. Let's go over test case 2 to make sure there aren't any gotchas. Again, we're looping through nums. We have it down here. Let's start at the first index 3. And our target is 6. Nums of I is 3. This gives us 3. Have we seen a 3 before? We haven't. So we move on. But before we do, we're going to add it to the map. And then we move on to the next one. 2. Like I said, target doesn't change. 6 minus 2 is 4. Have we seen a 4 before? Nope. So we move on. But before we do, we have just seen a 2. So we put the 2 and we move on. Next one is 4. Changes this math. 6 minus 4 is 2. Have we seen a 2 before? Yep, we have right here at index 1. So perfect. Since we've seen it before, we know that we have what's needed. So then we send the 2 in index 1 that we have before and the index that we're currently in right now, which is index 2. Gives us the answer 1 and 2, which is exactly right here. Now we've diagrammed it. We can see the logical steps that need to take in place for us to get the answer. Now we're going to turn that diagram into pseudocode. So the first thing we did was simply create a map variable. The second thing we're going to do is loop through the nums array. We're going to need that needed variable, set needed to target minus nums of I. And then we do the logic that we were always doing, which is if needed in map, then map get needed and the current index that we're at. So we're going to return an array of that. If it's not in there, set the one that we're in right now in the map so we can keep track of it. So map set nums of I, and then make sure to set the index of where we're at right now as well. If we go through all that and we don't return anything, then we just return an empty array and exit out. So that's it. That's the logic of the diagram that we just did. Now we're going to move to the easy part, which is just translating this pseudocode into actual code. Create map variable. Great. Loop through nums. Set needed to target minus nums of I. If needed is in map, return map.getNeeded and I. If not, set map to nums of I and its index. If we go through all of that and we don't come up to anything, we just return an empty array. And that's it. Let's run it and see if it works. Accepted. Awesome. We just did this easy one because I wanted to walk you through the 4-step process. We're going to go through more complicated examples. If there's an actual LeetCode exercise that you want me to go through and break down step by step, please post them in the comments. And if you're interested in this kind of stuff, please consider subscribing. Anyway, hope you enjoyed that. Bye.